Welcome back to another episode of the Engineering Future Podcast. I'm your host, Luis Duque. And this week, I bring a presentation from Robert Smith. He is an engineer from Rhode Island, and he has done some amazing work in ethics, and it was really inspiring to hear these stories. This episode is part one of two of a few stories that he's sharing with us from examples of good engineers and unfortunately bad engineers in terms of ethics. Robert, he's currently on the board of directors of the National Institute for Engineering Ethics, and he's also a national governor of the Order of the Engineer. He has spoken at many conferences to many groups about ethics, and is truly someone that has a lot of knowledge on this topic. And as young engineers, we typically don't think too much about ethics, but I think it's really important for us to realize that as engineers, even when we're students, we have a huge responsibility to serve the public and to always be ethical. And the more we understand what's ethical and what's not, the better we can practice the profession. So in this episode, Robert will share with us the story of the Citi Group Building, which was a really interesting story. As a structural engineer, I found it fascinating with all the little details and the little problems and roadblocks along the way. And is a great example of someone that at the beginning neglected to consider some of the loading scenarios and some of the things that the engineer should have analyzed for. But at the end, he came out with a solution that was fairly clever, and Robert will explain everything on this case. This was a case of a good engineer, someone that understood that he was doing something wrong and seek to fix it. And at the end of the day, they found a solution and everything was okay. On part two, he will share some stories from the Ford Pinto case, this GMC ignition case, as well as some other stories of engineers that did not practice good ethics. And unfortunately, there are engineers out there that are not really practicing with all the ethics and all the standards that we are supposed to be held accountable for. I've linked in the description a few resources about ethics, the Code of Ethics from ACE and from National Society of Professional Engineers for you to read, and hopefully you enjoyed this episode with Robert. And before I start, I just want to give a huge thank you to Chad Morrison, which was the person that sent me this video and encouraged me to share with all of you. So without further ado, let's just jump right into the presentation from Robert today. Welcome to the Engineering Our Future podcast, a podcast where I bring you relevant content from personal experience and guests to help young engineers, students, and international students succeed in their careers.
Hello, I'm Larry Smith, and I've been asked to give the capstone lecture on ethics again. I've been doing this for many years, and because of COVID-19, we're taping it. I also think that, given my advanced age, there's a belief that they better get this on tape in case I am no longer here or don't have the faculty to do it in the future. For a little bit of background, my credentials: I'm on the board of directors of the NIEE, National Institute of Engineering Ethics, and I had a fellowship in engineering ethics in the 1970s from the National Endowment for the Humanities for 3 years at RPI, and I'm on the National Board of Governors of the Order of the Engineer, the ring ceremony. Been lecturing down here at least 20 years on ethics. I've lectured at other schools. And just to prove the naysayers wrong, I'm going to do this without notes, and I've lived most of it. I'm going to start with the Citi Group Building, which was built in New York City on Lexington Avenue at 57th Street, I believe. It's a 69-story high building, but is somewhat unique. It sits on 4 columns 90 feet up in the air before they start counting floors. And the property was across from the Citi Group's original offices. They always wanted to buy it, but there was a church on the location, St. Philip's. And St. Philip's was old and run down, but they weren't willing to move. So the deal was that they would sell to the Citi Group but the church had to be maintained on the property. And Citigroup offered to build them a new one, modern, that would fit in with the proposed building. And that was accepted, but it was written into the sale that no part of the Citigroup building could touch the church. It had to be freestanding and apart. And the Planning Commission in New York had great plans for some open space on the property. So they came up with a great idea, spectacular idea. They would build the church, and above it, I'll take this out for now. On 4 columns, they would build the Citigroup building, and this was about 90 feet, 9 stories. And above that would be a 69-story building. And the church would sit under it, and on the other open side, they'd have open plaza for public use and seating. And there would be a center core with elevators in it. And this is a unique design that normally we would expect the columns to be here at the corners and carry the conventional loads. The architect was Stubbins, and they went to LeMessurier Associates, located in Cambridge. Bill LeMessurier was on the faculty at Tech, MIT, and was a world-renowned structural engineer. I just went to so I have to play it.
Yeah, what the, you know, I mean,
So the idea with which Mr. LeMessurier came up was a series of chevron frames, and instead of the load being carried down, it'd be picked up on these diagonals and brought to these center columns. I may have mentioned that the longest cantilever here was 75 feet. It's also cantilevered out in 2 directions for the corners. So this would carry all the loads to the center column and down. And everyone thought it was brilliant. Mr. LeMessurier thought it was so brilliant, he wanted the architect to have it exposed on the outside of the building. And the architect didn't think it was that notable. So it was in there, and Mr. LeMessurier said God would see it. And everything was fine. The building was built, was completed. They were occupying, they were leasing it, and a graduate student, and he was sent a copy of an article that appeared in the New Yorker. There was an error in it. The author was told that a graduate student had contacted Mr. LeMessurier, and he assumed an engineering graduate student would be a man, it was a woman. And she called Lemessurier, and Lemessurier always admitted to being an egotist, and saying she had questions. So he broke into a busy schedule and he spoke with her at length and explained a number of issues and a number of things and errors that her professor was making, and assured her that the columns were in the correct place, that was designed for that, and it was an outstanding design and was brilliant. And she shared some things with him that she had calculated. She was doing her master's thesis, and it was to recreate the calculations given the framing system. And he talked to her about different winds, etc. And hung up and got thinking about it. And he had some people look into it. And they found out there were some major issues. When it was designed, the columns, remember, were at the intermediate points. They had checked it for wind perpendicular to the faces of the building. Why? Because that's what the code required. As for what the code called. But the code wasn't written with this configuration in mind. It should have been checked for winds coming at the corner, what sailors refer to as quartering winds. And when they checked it for quartering winds, they found the stresses were much higher than they had originally expected. And you basically get forces working on two sides with quartering winds, whereas when you coming head on, you only have forces in one direction. And these can feed off each other. So, originally the design had called for all the connections to be welded on the diagonals. Weld. Those were all supposed to be welded, but interestingly, about 2 weeks before the young lady had contacted Mr. Lemessurier, he called the New York office. And this was designed in Cambridge, but the New York office was in charge of overseeing the construction, handling the submittals, etc., to ask him about the welding, because they were proposing another building, and the contractor said that the welding would be way too expensive, take too much time. They didn't have enough qualified welders, so they were just going to bolt it. And he called the New York office to find out if there was a long delay because of the welding, and had been told that, well, no, based on how strong the structure was, the contractor there had said the same thing. He didn't want to weld it, so they allowed him to go to bolts, and it was bolted at a considerable savings in time and money. And using the data they had from the wind loads, etc., they had checked the bolts and they were fine. And when they checked that, by the way, Murphy's Law, that if anything can go wrong, it will go wrong. Murphy was an optimist. When they checked the design, these members, diagonals, they didn't check them as columns. They were checked as part of a truss. If they had been checked as a column, it would have had a much higher factor of safety requirement. So the connections and the bolts were designed, one, with the wrong wind forces, and two, with a much lower factor of safety because it was treated as a truss, as a column. Mr. LeMessurier got very, very nervous, and he flew up to Canada, where there's an outstanding expert on wind loads, on structures, and they had done some of the original modeling, again based on the perpendicular wind loads, not the quarter. And they input that, and they kept running through it. And Mr. LeMessurier asked that they be honest with him. They came out and they told him, you got a problem. And based on their calculations, the structure could be taken down by a 16-year storm. And a 16-year storm is not tremendous winds. It's the storm that you can expect once every 16 years. And anything above that would be a danger. And Mr. LeMessurier came back, sat with some of his key people, and went off to think about it. And he knew this could ruin his reputation. It could bankrupt him. At one point, he considered committing suicide and figured that was the coward's way out, and knew he had to do something because lives could be at risk. And he contacted the architect contacted the Citi Group. The Citi Group, they finally got to somebody because they saw at the top and no one was taking their calls. They got to somebody and told them there was a major problem. They had to come down and speak to them. So they flew down to New York and they had a meeting, and interestingly it was held on the 30th floor of this building. And what's interesting about that is their calculations that they did for the ultimate repairs showed that the weakest point, the point most likely to fail, was on the 30th floor. So they were sitting next to it. And they came up with the idea of welding plates over each one of these bolted connections. And they thought it could be done at night. And they would have a drywall crew come in, cut out the drywall in each location, weld on the plates, knock off, and have a drywall crew come back in, restore it, paint it, so that the tenants wouldn't see anything different when they came in the morning, but they had to tell them. So they prepared a press release for the tenants, and the newspapers got hold of it. And the New York Times called Mr. LeMessurier, asking him why this work had to be done. So he went and had a few drinks and spoke to a lawyer, and they decided he had to get back to them. So he called the report, the New York Times, and an answer machine came on saying that because of the newspaper strike that had started that afternoon, no one was available. So he didn't have to deal with the press. They also installed strain gauges at key locations through the building, and they were going to have a full monitoring crew to watch the readings from those. So if they started to get heavy winds, they would know if the building had to be evacuated. And that was installed. And interestingly, when it was installed in a rush, they didn't use union labor. And while the work was going on, they were monitoring. They suddenly lost all the signals. And they found that all the lines from the strain gauges had been cut in multiple locations. They were never able to get it back up. They always attributed that to payback for not using the union. No one's sure. They also met with the city to let the city know why they were doing this, and asked them to be very quiet about it. And the building had a tuned mass damper at the top. It was basically a huge block of concrete floating on oil, held by springs and electrical system. And its mass would repel movement of the building. And they do that in a lot of high-rises, skyscrapers, keep people from getting seasick up at the top. And that was considered critical in keeping this building safe till the repairs could be made. So they brought in a crew to babysit it and installed emergency generators, because they realized in a hurricane were to come, they were going to lose the power. So they took that into account, and they went in and they started welding on the 30th floor. And I don't know how they figured out that that was the key point. It's beyond me. But as they welded it, they would redo their calculations and come up with the next critical point. So they kept hopping around through the building, and they were about halfway through when a named Hurricane Ella, was coming up the coast, was passing Cape Hatteras, and the early predictions were it was going to hit New York City. And that's when the real panic set in. Incidentally, the Red Cross, after this all came out, did an estimate if the building had collapsed towards the north, which was probable, and all the buildings were occupied at the time, between 200,000 and 250,000 people could be killed. And it would be a domino effect of building collapsing after building. Someone was on their side, because the storm veered from going west and turned to the northeast and passed out to sea and didn't hit New York City. They finished the work, and Mr. LeMessurier was considered a hero instead of a goat, because not only had he identified the problem, but he came with a solution. And it's a solution that worked. And while they were doing the work, they did some other bracing. And when it was done, they had the wind specialists rerun their calcs, and it would withstand a 700-year storm. So he became a hero. It's one of the cases where the fix works. When the Tower of Pisa was being built, it started sinking immediately. So when the first floor was up, it had tilted. So the builders decided they would lengthen the columns on the side that had tilted, so the next floor would be level, not realizing that they were increasing the load on the side that was weak and sinking. That wasn't something that worked, but his did. And interestingly, Citi Group settled for his insurance limit. They didn't want any contribution from him or his firm, just up to the insurance. And they ate the rest. And even more incredibly, his insurance company didn't count it in his rate experience, because they were just so thrilled that it had been resolved. So here's a case of somebody faced up to the problem, came out and admitted it, and came with a solution. And if there's a problem, you can't just hide it.
So that's the episode for today with Robert. Again, he shares some amazing stories and some amazing cases of engineers that are being ethical in their profession, even though we sometimes may make mistakes kind of early on, which was something we saw in this episode. It's always important to understand and acknowledge the mistakes and seek to fix them, because a lot of lives depend on our calculations and our work, especially as structural engineers with bridges and buildings that hundreds, if not thousands of people are using on a daily basis. It's really important to practice with the most amount of ethics possible. As I said, this is part 1 of 2. So next episode I'll be sharing with you a couple more stories from Robert of unethical engineers and kind of the other side of the coin that unfortunately happens sometimes. And honestly, we just need to keeping each other accountable and just bring in the code of ethics, the ASC code of ethics, as well as the NSP code of ethics, which I've linked again in the description below. Again, thank you so much for coming back to this episode. I would really appreciate if you rate and review the show on Apple Podcasts. It really helps get the word out there and really helps the show grow and continue reaching more and more people, which is a huge goal of mine this year. I've been working really hard to bring episodes every single week with some amazing guests. Every Devon last week were amazing with Bridges to Prosperity, and I have some really incredible guests kind of coming up in the coming weeks. So thank you so much for coming back to this episode. Thank you again, Jack Winters, for the music. I'll talk to you in the next one, but for now, let's continue engineering our future.